Where I've been spending time is still working on the IMU. I've had to, so I've been messing with the IMU, sitting at the kitchen table with the IMU connected to my computer. So trying to move that to the tractor. For me, I've had to add another USB port to my physical box, and then try to remotely program that. I had to run into an issue where to do that, I needed to get to an updated version of Platform IO because I was trying to program with a Nano, and evidently I hadn't, it's the first time that I had tried to use a Nano with Platform IO. So Platform IO wanted to install a new driver. It didn't have the driver. It tried to load the driver and it said, oh, you have an old version of Platform IO. And then it said, oh, you need a new version of Platform IO in order to get that driver. Oh, you're running Ubuntu 16.04. Well, you can't. To make a long story short, I gave up on trying to get Platform IO upgraded. So I'm going to have to do all my programming on the Nano, not connected to the tractor, and then or switch over to a Teensy, which Platform IO is configured to update remotely and run on 16.04. So at the moment, I'm just going to update the Nano offline and then move the Nano and IMU to the tractor and try to continue that. So I've been fighting with updating the IMU and continuing to get that to work. So that's where I'm at. And then I had a question for you. I was noticing that you had written a little script to output to serial, and then another Python or another ROS node to read that serial script and turn that into the ROS topic. Is that what you're intending to run in production? I was just curious why you didn't just.
That's at the moment, that's just for debug, where I can get tons of information out of my device and put it into a topic and then put it in a ROS bag and then come back with plot juggler and then plot all that stuff. For production, ideally, I'd like to find somebody's ROS node that goes directly with the device and actually works and go that way. And I don't want to have to write any more publishers than I absolutely have to, but you know, if I can't find something that does what I need, then I'm willing to hack something together to do that.
Yeah, let me see if I can find quickly. I mean, I have something from a long time ago. I mean, it was just a plain Jane IMU reader. Bum, 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 bum. I'm searching for it here. Oh, come on. I gotta search the right place. Yeah, I found what I was looking for. Where's that daggone? Where's the come back? Zoom. Share button, please. Why is that window not wanting to open? There we go. So this was a long time ago, messing around with the IMUBrick. I don't remember exactly this, but it was just taking the quaternion and so it was bringing that in. And publishing the message. So I mean, I can.
Yeah, at the top there, it said you're publishing an IMU message.
Yeah.
You created a publisher. Yeah, right there at the top, it says IMU. So apparently it's an actual IMU message that you're publishing.
Yeah, it's been a long time, and I noticed this. I'm like, holy cow, I forgot. I mean, this goes back to like 20, I don't know, 18 or something. And I tried to plug in my IMUBrick, and I think it's broken. So anyway, if this would be of any help, you could. I'm happy to. But then I don't remember this. I'm like, where did that come from? And I saw these covariance numbers down there, and I'm like, I wonder where that came from.
Yeah, there's various IMU drivers floating around out there, and some of them have more output. Yours apparently is just putting out the IMU message. Sometimes they'll have a raw message. Sometimes they'll have one that just says raw message that has like the accelerometer gyroscope. And then somebody else said, well, we're going to get the magnetometer data, but I think they used another raw message. So anyway, there's like 3 or 4 different standard messages that you can use for IMUs, and I don't recall what they are. But at this point, I just prefer to get somebody's that's already put together and claims it works, and start with that and see what happens there.
Well, again, this one was specifically around this particular. I think these guys are out of over in Germany, Brick IMU, which is an odd name for an electronics device, but anyway, I thought I would share that stumbling across. It's like coming across something that's in your attic you've forgotten about a long time ago.
So I'm still at the point where I'm just trying to get all my sensors to work and trying to verify the data coming out of them makes sense. And I realized very quickly that I'm still confused on orientations and which frame I'm in and all that kind of stuff. And that just to add to the mix, the fact that all the GPS stuff runs in what a normal person would use. They use the northeast down coordinate system, like if you pull a compass out of your pocket, the needle points north and east is 90 degrees from there, which in ROS, east is 0 degrees and the rotation is backwards. And so if I try to plot, if I just pull up the data from the GPS and plot it, say with Plot Juggler directly, it makes sense on the screen, but of course that's not what ROS wants to see. So that if I try to put in RViz, and so RViz plots out, say the odometry goes in one direction and goes off somewhere, and the GPS goes off somewhere else because they're in the two different coordinate frames. So I gotta still figure out where's the magic dividing line between that. When do you actually switch that, and then how do you move forward with that? So that's kind of where I'm at this point, just realizing that I have to figure that out and do something with that.
When you say, I mean, I don't know if I have it on this machine or not. I mean, I had to create a diagram just to get it in my own head. I mean, around the whole 2 pi and at 0, or are we talking about east? Or are we talking about human readable east? Or are we talking about what Ross wants to see east at?
Well, eventually on a working system, you figure out there's something in there that translates from whatever the GPS puts out into whatever Ross wants to see. And as long as you don't go back and try to plot the original GPS data at the same time, you don't have a problem, because once everything's in ROS mode, you look at it in RViz and everything should line up and go the right directions and all that. It's just that if you're trying to look at that and trying to look at the original GPS stuff, which is different, then you can't plot them on top of each other. And it's not really a big deal. I just have to go through. And speaking of going through all these things, I was looking at the stuff on the Ross Agriculture site, and there originally Matt said use the NEMA Navsat driver. We can just take it right off the main repository and use it. And then it looks like he wrote something called GPS ODOM-PI that subscribes to fix. So it converts latitude and longitude, subtracts off your local origin, and puts out an offset in meters.
Yep.
That also subscribes to something called heading. Now, I noticed originally there was a GPS heading.py that would subscribe to the velocity message from the NEMA Navsat driver, and then publish a quaternion called heading that the GPS odom.py wants to have. And then the more I dug, I found that now that's been moved back into the NEMA Navsat driver. I see there's been a lot of hacking done on that. So it's got it directly publishes that heading quaternion. So you don't need the GPS heading.py at all anymore. And then it also publishes a speed value. And there's various things in there talking about fixing errors. And there's something about generate NaN values based on something. So anyway, I was playing with that GPS heading.py, and it would subscribe to the velocity message, which is a XY speed vector. And then by taking the arctangent of like X over Y, it tells you can extract the heading back out of that. So you can get a heading either in radians or in degrees. And I thought, well, gee, the forward velocity should be in there somehow. And I did a bunch of digging, and I found this page that says, how do you convert vectors back and forth? Well, it turns out it's just you're forming a right triangle, and the vector, which represents where you're going, the length of it is your speed, and the angle is your heading. So all you got to do is you just take the square root of x squared plus y squared to find the length of that. So I took that heading.py, or the GPS heading.py, and I said, read the velocity. And I did the arctangent thing to give me the heading. And I did the square root of x squared plus y squared. And that does retrieve the velocity out of that. So I modified it. Instead of, Matt had it set up, he said, if the values coming in were NaN values, then that's invalid data. And he may have had to hack the NEMA Navsat driver to create NaN values in the first place. But I'm getting directly velocity out of that now. And I just say if velocity is less than 1/10 of a meter per second, use the latched value. If it's greater than that, pass the value through. And that does appear to work, but I say I still got a few little noise glitches on that. So theoretically, once I clean this up, you should be able to connect that to anybody's GPS driver, whether it's the NEMA Navsat driver or the Swift Nav that Juan is using, or the FP9, uBlox FP9 that I and Javi are using. You know, all of those put out those two standard messages, the fix and the velocity. So that way you wouldn't have to have a hacked version of NEMA Navsat driver. And in your case, you could run the Novotel driver on your box, I believe. And again, get those two standard messages, plus, like I'm doing, get tons of extra information. You know, just if you get the desire to do that, I think it should be possible to get all the extra information out.
Yeah, thanks for that.
So anyway, I was playing with that. I can now extract the heading and the velocity from that velocity message from any of the drivers, and I'll play around with that some more and see what I can do. And then again, it comes back to the fact, you know, which direction of rotation do I want and all that kind of stuff. That's where I'm trying to figure out that magic line between the two, because that GPS odom.pi, I don't know if that's correcting for the northeast down to east north up. In other words, are the values coming out of that in the values that the ROS wants, or is it still in the values that GPS is putting out? Because I don't know. I haven't looked to see after that what people are doing that with that. Are they, you know, directly feeding that into the navigation stuff, or is there another node in between that's trying to convert that into something ROS wants? So that's just where I'm at the moment, is trying to figure that stuff out.
And I don't know if it's helpful or not. I mean, I'll put this URL in the chat. I mean, that was some time ago. I created this little cheat sheet for me. I forget exactly what prompted me to do it, but you know, I was like, okay, I'm familiar with the human readable number of 90 degrees east, 360 for north, and 270 for west, and 180 for south. And then we know that in radians, you you can go for 2 pi, but I think what I was dealing with was something that was outputting 1 pi positive and 1 pi negative in radians. I forget. And so I was just trying to plot out, well, when was it changing, and what. So anyway, it was just a cheat sheet that I had done for myself. Not that it's whatever.
So this presentation we're looking at, is that on your computer, or is out on the internet somewhere?
No, I just created this diagram for myself. That's what we're looking at.
Yeah, I know, but the thing we're looking at right now, is that on your computer, or is that out on GitHub, or is that out on
it's a PowerPoint
Google
slide
Drive
on my computer.
Okay.
I don't know if there's a, does chat take a,
I don't know.
Slack will take a,
you could just do a screenshot and load that into the Slack.
Yeah.
And oh, here it is. I've got a little Post-it note stuck on my computer, because in Windows 10, I have to do a Windows plus Shift plus S. And then it says what part of the screen you want. So on Linux, I just hit the print screen button and it works. Again, depending on the version of Linux, I notice I'm running 2 versions of Linux. I got 1604 on the robot, and I've got 2004 on the one I normally use. And the differences between those I find very annoying. On one of them, I've hit print screen, it will automatically print the screen and save it to pictures. The other one, if I hit print screen, it pops up, says, what do you want to do with this? You know, just things like that. And then of course the scroll bars are always, you know, for the last 5 to 10 years, the scroll bars don't work anymore, and I have to go fix those. And I haven't fixed it on the robot computer, so I'm usually yelling and screaming. I'll click somewhere, and it, instead of doing what I want, it does what they want it to do. So anyway, just more complaints about trying to run multiple versions really gets to be annoying.
What triggered it is you talked about, and I don't, you weren't necessarily trying to figure it out like I was, but when you talked about trying to figure out the dividing line, it reminded me of trying to figure out, I think I was doing some calculations and trying to figure out the 270.1 or 269.9, and that was the whether I was above that line or below that line. Anyway,
My point was, I know that you have to do this somewhere where, Ross thinks east is 0 and the counterclockwise rotation is positive, and somewhere that has to be done. So somewhere between your GPS and between where Ross wants to use it, that has to happen. And my question is, where should that happen, and what would make that, what would be the easiest way to do that? So I don't recall looking at the GPS ODOM Pi specifically saying we are taking care of that problem. So I don't know what's coming out of there, if it's still in GPS or if it's in ROS conventions at that point. But I think if you look at that NavSat transform node that comes with the robot localization stuff, I think right in there, there might be a parameter that says convert, or it may just automatically convert it for you. So again, I'm just trying to figure out, where should that happen? And at this point, I think I'm going to go back through the NavSat transform, since that was written by people that actually know how this stuff works and actually use it in, production people are using this stuff. I assume it's thought out a little more than some of the stuff that got hacked up for ROS agriculture. So I just want to try to go through and figure out, in my own mind, how should this work and how does it work, and be able to just pull it up and display it and know that what I'm looking at is correct. Because I'm still confused on, I drive around and think, well, what should this look like on the screen? And because right now, if I pull up my wheel odometry and plot the XY plot from that, and then pull up the, say, the output of GPS ODOM, well, the GPS ODOM, I believe, looks just like the GPS stuff I put into it. So I don't think it's doing the conversion, but I go look at my odometry, and my odometry is mirrored in the X direction. And when I say X direction, I mean plotting that with plot juggler, like a mathematical plot.
yeah,
It's mirrored in the X direction. So again, it gets confusing trying to look at the different things at the same time. And it could be I just need to quit looking at the raw GPS stuff, or I just need to say, okay, I'm going to look at all the raw GPS stuff now, and then switch over and look at all the ROS stuff, which should be converted, and then everything on either side of the imaginary line, things should line up. So maybe that I just need to get that procedure figured out to be able to do that.
so did you write your own code on converting your wheel encoder clicks into an ODOM message, or did you borrow somebody's?
Basically, they're just standard equations to do all that stuff, and I just did, what they did. And at the time, I said, okay, based on ROS, going forward is a positive number, and going to the left is a positive number, and this kind of stuff. And I just whipped up the output for that. And I believe that's correct. If I sit there and look at it on a screen, or look at the numbers coming out and say, if I drive like this, it should do this. That all seems to be working correctly for what ROS wants. It's just that what ROS wants is not what GPS is putting out. So again, I just have to go back and figure out, where that translation should happen, because I don't see it happening in the ROS agriculture stuff right now. So it could be that, a lot of this stuff, you put it together so far and it's putting out this, and it's not working. So you say, oh, down the line, oh, I'll just flip the axis on that, or I'll just add 90 degrees to it, or whatever.
Right.
And that's a lot of that happens, and it just gets passed on and on. So you got to be careful of that. That's why it's better to go back and figure out what's really happening, and figure out what should really be happening at that point, and either fix it, or at least make note for people that say, well, this is what you're getting into.
Yeah, because obviously I'm using the GPS ODOM.py thing too. So if that's not creating a good XY number, I'm screwed too. So,
and probably what you're going to see, it's either going to be, your turn's going to be reversed, or your XY plot on the you know, if you plot it out on something, you know, in your yard, it's going to say it's going this way, but it's really going that way, that type of thing. So, and again, as I say, most people, they'll just hack it and say, okay, I'll just flip that axis. That'll solve my problem for the moment. And, you know, they never seem to go back and fix that. So we'll see what happens on that.
I forget what was at this URL on this Stack Exchange. So take a quick look at that. It's probably people just talking about that interface or that naming standard. No, they're just talking about math.
And something else I've been noticing that, you know, as I go through programs and people have written, no matter where they come from, you know, somebody will just write their own code to say, do a radian to degree translate or do this kind of scale. And then other ones I noticed in a Python at the top, they'll say import math, and it's got all those functions in there. So you don't have to write your own little functions. So that would be another thing to go through and clean up a lot of stuff and say, you know, take the actual Python function to convert radians to degrees or whatever it is you want to do. And that would be another thing to clean up this stuff.
I thought you were the don't use anybody else's libraries guy.
No, I'm the guy that I'll just grab somebody's software and hack on it, you know, like Matt does. So I'll just grab somebody's software and hack on it, leave all the imports that don't belong, leave all the labels that are wrong, have extra stuff that there's not used. That's the way I do stuff. I do it just the way he does it. And as far as other libraries, well, it depends. You're talking about a function, you're talking about a library, because if you say a library, like getting somebody's PID library, when it only takes a few lines of code to do that, as opposed to grabbing a function, a pre-written function, which speaking of pre-written stuff, I noticed I went through and took Kyler's Dubin's path planner or path generator stuff that he pointed to on his YouTube channel. And I looked at that whole thing. It was I think it was in Python, and I had to figure out how all that stuff worked. And I had converted it over to C in order to put it on our controller there at work to play with it. And it turns out Python, you say import Dubin's, and it's right there. It's ready to go. And I didn't. There's Dubin's and there's something else. Maybe even the Pure Pursuit. You might be able to say import Pure Pursuit, and you don't have to write any of that code. And I'm all for that. If it loads up and it works and I don't have to figure it out, that's to me, that's great if you can get that kind of stuff to work. Rather than writing, you know, 10 or 20 pages of code or taking somebody else's 10 or 20 pages of code and try to figure it out and then try to modify it. So another thing that I'm going through, for some reason, my remote control doesn't work all the time, and I can't figure out why. And I thought it was at the point if I bang on the transmitter a little bit, it would work, or if I bang on the robot a little bit, it would work. But that might be my imagination. And I do notice that it's connected because the little LED on my transmitter is flickering at a fast rate, which means it's talking back and forth. If I flip the switch on it that says I've got a manual / auto, which auto would be listen to the ROS stuff. When I flip that, my beacon changes from orange to blue. Or if I hit the e-stop button on the transmitter, the beacon starts flashing red. But for some reason, the relay won't engage when it's supposed to. And I do have, there's an LED on the receiver board that's a red-green LED. And if it's red, that means it thinks that the transmitter is sending an e-stop condition. And if it's green, it says everything's good and it should turn the relay on to let everything run. And for some reason, as I say, if I hit the e-stop, the LEDs change from one color to another. So I know I'm communicating. It's going all the way over the CAN bus to the microcontroller. That's how the beacon's controlled. But for some reason, the relay doesn't go. It could be I got loose jumper wires going out to the relay, although that doesn't explain why the LED on the receiver board isn't changing. So there's something funny going on there. And I always thought, at one point, I thought it might just be interference in the neighborhood where somebody's got something on the same frequency. But since I can get the LEDs to change by flipping switches or hitting the e-stop, that's not the problem. So I need to get some debug stuff put on that, try to track that down. But it's pretty annoying. I get it all set up to go, and I say go, and it's just sitting there ignoring me, and I have to stand there for a few minutes, and then sometimes it'll randomly, the relay will click in, and I can go drive around. And sometimes while I was driving, it'll come to a stop for half a second, and then start running again, because there's some kind of interference on the remote, and I haven't figured out what that is.
And remind me, what do you have your remote handy? What who makes it?
That's that one I built myself, where I got a $4 box from Harbor Freight and bought the LoRa radio from Adafruit, and I put 2 joysticks on top of it. So it's that thing I built myself, and I took the Adafruit sample code and loaded into the 2 LoRa radios, one at each end, and I can just send packets back and forth.
But the actual trend, the radio frequency is like 915 on LoRa.
Yeah, it's got some, I think it's got some standard frequency, or maybe there's several channels out there. And I was never sure about that, if you could run, 2 of these side by side, or because there's something else, they have a number that's something about, I think you just pick a random number between like 1 and 33, and those essentially act like channels, but they're not really channels, because I think LoRa radio is what they call spread spectrum frequency hopping, which means it's constantly switching over like 50 different frequencies or something in a random order. But it's not a random order, it's based on that, I think based on that number I just said, like 0 to 33, it picks whatever order it is. So technically, just somebody with, say, a garage door opener or something, I don't think should kill the communication, but I don't know. I at this point, I'm baffled, and I just haven't looked into it.
Was it Adafruit's LoRa chip?
What's that?
Who did you get the radio module from?
I bought that from Adafruit, and that they sell a certain brand, and if you go to Sparkfun, I think they sell a different brand. If you go look on eBay, they have different brands. So I don't know if the different brands will cross communicate or not, and that's something else I haven't tried. I just bought 2 identical ones from Adafruit, and that's what I'm using, and that seems to work.
Yeah, because I really like Adafruit stuff. I'm just looking at their
and I went through several iterations on that. First, I bought that one. It's called the M0 LoRa radio feather board or something like that. So it's basically a little Arduino type board with a radio soldered down to it. And on the transmitter, it worked great because I just configured it, plugged all the stuff into it, and worked, except it doesn't have enough IO pins. I ran out of IO pins for hooking up switches and push buttons and so forth. And then on the receiver side, I started with that same board, but I decided I wanted the CAN interface, and that processor does not have the CAN peripheral built into it. So that's where I went back to Adafruit and said I bought an adapter board that adapts a Teensy 3.2 to the Feather standard, and then I got their Feather radio without a processor and plugged that in. So I got basically 3 boards stacked up to make that work, but it's still the same radio module at both ends. It's just packaged differently on those.
The reason I'm probing is because my ESOP is just a cheap 415 megahertz board, and swapping that out for LoRa would be better, and I've just never got around to that.
Yeah, Bob was saying he wants to build something similar to what I have too. So one of these days he's gonna probably go down that path. So we'll have more people interested in trying to do the same thing. But my whole point was it's intermittent and it's real annoying. So that's just one of the things that gets in my way when I try to test. So the other problem I have, so I fired it up yesterday, started up the laptop, and packaged everything up, and drove all the way around the block. And when I came back, I saw that it was putting out a message that said ASIO error from your FP9 receiver module, which means somewhere along the line, the USB interface died between that, and it spammed my log file with all that stuff. So, and unfortunately, since I say record all on the ROS bag, my log file got put in there. So when I was copying from one computer to other, I had a 10 gigabyte bag file that I'm sure was all just the errors from that. So one note is I need to go back and change it from ROS bag -A and say ROS bag and list out all the topics I want, and don't list the log files, or there's a few others I don't need either. So that would solve that. But it's just the fact that that's another annoying problem where just randomly my interface will die talking to the F9P receivers, and I don't know why. So that's another thing. And if I go back and get my LED status strip hooked up and running, then if I see the light drops from green to red on my GPS, I say, oh, it just died. So there's no sense, spending another half an hour driving around if it's not running. So that would be another handy thing to add to it.
Man, that stability stuff is a pain in the butt.
I fixed several things and made them work better now, but now I'm back to this standard driver from the ROS group that just randomly comes up and complains. And I don't know if it's their driver, or it's something they did in the driver, or if it's the Linux level. It could be something in Linux was unhappy and Linux kicked it out. But I don't know. That's just another thing I have to go track down.
How about the local robotics guys? Anything interesting going on there?
We just had a meeting last night, and I don't recall. Christian was talking about his robot arm. He's got a Puma 500, which is one of these big industrial robot arms from 20 years ago. And he plays with that and tries to get that to work. And he's trying to get a Raspberry Pi 4 with real-time extensions loaded on it. So he's trying to do real-time programming with like a 50,000 update per second PID loop to run his arm. And I was telling him, don't do it that way. Just get a separate controller to control the motors, and then have your high level computer just do non-real time stuff. But he said he's going to go a little farther on it before he gives up. So, and he said last night, he says, "Oh, I'll see you on the meeting tomorrow." So I thought he would be on this meeting. So either he forgot, or he's had something else going on.
50,000 cycles.
I thought that seemed fairly extreme, but just fact he's trying to run real time stuff under Linux, to me that's always a red flag, even though people say you can do that. And he was also prompted by the fact, if you get that CNC Linux, because everybody builds those desktop CNC machines, or they'll hook it up to an actual like Bridgeport CNC, and they've got an old copy of Linux that's 20 years old that somebody loaded real-time extensions on. They wrote all the real-time code in that to update. I think they had stepper motors or something, and they're updating all that in real time, so that lets people think, oh, that's the way I should do it, because somebody did this a long time ago and barely got it to work, and people have been fighting with it for the last 20 years. I think I should do my new stuff that way. So you got to be careful that kind of approach too.
Yeah, we have, let me see if I can find it quickly. I mean, in the world of industrial controls and PLCs, there are guys out there starting to use Raspberry Pis, but I'm wondering, let me see if I can find one of the suppliers.
I saw one where somebody taken an actual Arduino and built a plastic box to put it in, and they're calling that a PLC. And I don't recall on the Raspberry Pis, how they package those, or if it's just simply the software you load on them to make them act like a PLC.
Well, what I can't say as I sit here is whether there's some other processor sitting in, and they just use the. I'm looking through a list here. Bear with me. They have something on top of it. Oh shoot! Come on, find it. I'm getting close. Ah. Okay. Now, how do I get to, I'm almost there. I'm looking through a list of chat messages in a software product called Teams, and I'm fighting with how to get to a particular date. So I need to go to June 12th now. How do I get to June 12th? Well, there's the hard way. And I bet there's an easy way, but I don't know the easy way. Come on. Boy, you better be impressed with this company. It takes me so long to get to find the name.
I could probably find it quicker on Google by just typing in Raspberry Pi 4 PLC.
Yeah, you might. But this is the one. It's not just anybody. Okay. Optically isolated SSRs, opto22.com. There we go. Chat, chat. These are the guys that we think are pretty pretty snazzy.
Do you want to put up a screenshot of that so anybody watching the recording will at least see it?
Yeah, what they're typically, PLCs have been pretty proprietary, and these guys are making them a little bit more open.
They basically still have the same form factor as an actual PLC, you know, the industrial way of doing things. So you got a controller and you got the modules you plug into it.
And it's, I mean, they're saying they have a real-time Linux. And, you know, it's modern day real time. It's not like you were saying something hacked a long time ago. Now that is probably their distribution, but at least it's supportable. I haven't checked. I'd have to ask the guys, but if their distribution is available.
So you think that's somehow related to Raspberry Pi? I didn't see anything mentioned there on the page you had pulled up, that that's what they're actually using.
Yeah, let me, I have to find it.
And it's good as a curiosity. At this point, I don't plan to switch over to anything like this.
Yeah, no, nor do I. I think it's a $1,500 device. Where did they tell me that they had a Pi version?
And they're using the term RIO, which is the RIO. That's a term that whoever builds those computers, National Instruments, that they build that, and that's what everybody's putting on those first robotics things. So they had a National Instruments RIO computer. So I don't know if RIO stands for real time something, or if they just both happen to choose the same name.
Can you see this?
Yeah, I can see that. It looks like an adapter board. You plug in a Raspberry Pi and you plug it on top of your standard Opto22 expander board. So
right.
That's would save some wiring if you do that. And speaking of wiring, I noticed the what was it? They just released something. Oh, on Sparkfun today, they came out and said, oh, we've got this new like I was talking about doing the status strip, where I'd take the long strips of LEDs, cut off what I want, hook it up to an Arduino Nano to display random status on it. Well, they've got a little board that's got 10 LEDs soldered down to it. It's got that Qwiic interface, like the same interface you're using to connect your IMU. You know, it's that little cable that you hook up to it. So they've got lots of different modules that have that Qwiic interface. You just daisy chain them together, which saves a lot of wiring. But the problem is, once they do that, then people think, well, I'm going to run that all the full length of my vehicle. Now you're running I²C a long distance you shouldn't be. So Sparkfun came up with the concept. They got these little adapters you plug into the Qwiic interface, and then you plug it, use an Ethernet cable as the long distance cable, and you put a module at the other end and convert it back to Qwiic. So it's real handy, but then everybody thinks they should use it for mainline communication on everything. So, you know, they go down these little pathways, and in my opinion, they're going to get themselves in trouble by doing that.
I mean, don't you think, I mean, in your opinion though, isn't CAN a better solution if you want to?
If you're going to run long distance in a noisy environment, CAN is better. RS485 is better. There's probably even USB. I think USB is a differential interface. So probably any of those are, they're all going to be better than I²C, which was designed to connect two chips together side by side on a board with pull-up resistors. So they weren't meant to, you know, run several feet or in a noisy environment. But they're making it work, and it makes it it's real cute and easy to do. You just buy their little adapter cables, you buy the modules, plug them together, and you're ready to go.
Yeah, I mean, for maybe a one-shot deal, if you had to, maybe, you know, but like you said, I'm not sure I would want to build the solution around that.
Well, weren't you having problems on your lawn tractor? You had those magnetic sensors, and you tried to run the wires back to your box for your TNC, and you're picking up noise on those, and it was causing problems?
I was.
Because that's the exact same thing. That's just basically the Qwiic interface without the connectors. It was And so that tells you right there, if you run it any distance, you're going to have problems, at least in a noisy environment. So there, and you solve that by putting a processor right next to it, just a couple inches of wire, and that keeps that interface happy, and then you run it back over USB to your main computer.
And
So
I
yeah,
think
there's lots of solutions to this stuff.
I think the source of EMI was the I don't know what the name of the apparatus is, but whatever is in the engine that charges the battery, whatever generates that electrical current, interestingly enough, is not continuously on, and it comes on every couple of minutes. Whenever that would kick on, my sensor would go crazy.
Yeah, on something like that, where you've got a gasoline engine and it's a somewhat industrial device, because on your engine, it's got the magneto generating the spark, and that's going to put out pulses that could cause problems, especially like on your analog interfaces. And then your alternator that you're talking about, yours apparently is smart enough to have an actual voltage regulator. Mine doesn't. Mine just takes the alternator and a diode and hooks it right to the battery. So I'm surprised it hasn't ever fried the battery over the years on that. So mine wouldn't have the same problem yours does, but you have that. And then your power steering motor possibly is going to generate a lot of noise. So there's all kinds of noise sources that could cause problems in a situation like this. And that, as you found out, then you had to find out ways to work around that.
Anyway, so that's what's going on in my world. Still trying to get the IMU data ingested in so I can have heading and rotational velocity data to play around with.
Another thing, I don't know if I mentioned this in the last meeting, I don't think I posted it to Slack, but I was looking at whether you got the BNO055 or the BNO085. And let me stop right there. I was trying to convince you last time it's the same driver for both of those chips, but I was looking at Adafruit. No, it turns out they do have a separate driver for the BNO055 and one for the BNO085. And it looks like they're written by different people. So there is a significant difference between those. But anyway, when I was playing with my sensor, and I said, I was looking at the calibration values coming out of it. And normally, if you just bolt it down and drive around, I noticed it doesn't attempt to calibrate at all while you're doing that. So I did an actual experiment where I went out, turned the thing on, pick up the front end, turned it back and forth like this, put it down and moved around. I think I was showing that plot of how he's doing that. And it said it was fully calibrated. Now it turns out even on the Adafruit BNO055 examples, it says, here is code that will read the calibration values out of the chip. And then the next time you start it up, you can write those back in there. So it could be if I get my thing fully calibrated that way, and the next time I turn it on, just shove the values back in, it would immediately go to a calibrated status. And that way I wouldn't have to monkey around and do anything fancy, because especially if you have a garden tractor, lawn tractor, and those are heavy enough, you can't just pick up the front end like I'm doing. You can't pick it up and spin it around. So I don't know how you would do the calibration on that. But once you get the calibration done, if you could save those values out and then load them back in later, that would solve a lot of problems. What I thought about on a lawn tractor, if you happen to have a hill in your yard or go to a local park where you got nice grass, and then there's a slope that goes up, like a 20-degree slope that goes up the side, take your lawn tractor and drive around, do a circle that goes from flat ground up onto that, because that's going to give you a tilt as you're going on it. And as you're going in a circle, it's going to give you a yaw. So you might be able to calibrate it that way. But the thing is, we should look into how do you save the calibration data out once it's calibrated. And that way you've got those numbers sitting there. So as long as you don't move the IMU on the vehicle, you should be able to put those back in next time and make it work. And I'm pretty sure this works for either the BNO055 or the BNO085. So that's something else we need to look at. And the other thing is, on the BNO085, I showed a plot where I did that and got it to calibrate, and I started driving around, and then it dropped back down to a 2, and then it dropped to a 1, it came back up to a 2, popped up to a 3, dropped back down to a 2. And I'm thinking, what would happen if you're driving along and the calibration says, oh, it just dropped out for whatever reason? Can I just slam the numbers back in? and force it back to a calibrated status and keep going? Or is that going to cause other problems? So that's another thing that we could experiment with sometime to see what that ends up doing. But back to the original stuff, I found out that if I just strap it on with a rubber band, point it north, turn it on, and go drive around, it was tracking my dual baseline heading quite well. But it probably worked better if I had some calibration done to the magnetometer first. So that's still, still more investigations to be done with that stuff to figure out how to get that to work better in the long run.
I'm still dubious about mine. You actually pointing due north when you start it up. I think I'm going to have to figure out north and tear it at north, start it at north and tear it at north, or get it going to north and tear it. But that's just a guess at the moment.
Yeah, the main thing now is get it bolted on there and go drive around, see how it acts, and then you can decide. Don't make up a lot of plans right now, because it could be you don't have to do any of that, or you're gonna have to do something totally different anyway. So the best thing would be getting values coming out and see how the thing's acting.
Agree with that 100%. Oh, so many little stones in the road.
Yeah, every sensor you add on, it's a whole nother journey trying to figure out how to get it to work and what to do with the data. And when it's not working right, how do you fix it? So
Man.
I think you've run into that. I think you know what I'm talking about.
Every one of them, every flipping one of them. It's like, hasn't anybody done this before? Okay, I'm going to let you go.
Okay.
Happy hunting.
Okay, see you later.